Today on How It's Made. Motorcycle sidecars. Frozen French toast. Refrigerator compressors. And superchargers. A sidecar is a passenger attachment that bolts to a motorcycle. Sidecars are aftermarket products, meaning a separate company, not the motorcycle maker, manufactures and markets them. You buy a model that's compatible with your motorcycle. A motorcycle sidecar carries one passenger or two if they're small children or pets. Manufacturers typically produce several models designed to fit the most popular bikes on the market. This one has a fiberglass body surrounded by a steel perimeter chassis. Workers construct the chassis using several sections of steel tubing. They form each section to the required shape on a hydraulic bender, measuring as they go. There are sections in the front and back, along the sides and underneath. Once the sections are each bent to specifications, workers clamp them into a jig, which aligns them all in the correct configuration. The smaller diameter sections fit into adjoining larger diameter ones. Once all the parts are in position, a welder fuses them. The structure of the perimeter chassis is now complete and ready for a coat of baked-on powder paint to prevent the steel from rusting. Next, workers mount the suspension and wheel to the chassis. Then install a fiberglass mudguard that has a reflector, a tail light, and a turn signal. They make the sidecar's fiberglass body with upper and lower molds, first painting each one with gel coat, a polyester resin that creates a smooth and shiny surface over fiberglass. When the gel coat dries, about 45 minutes later, they lay fiberglass mat over it, then saturate the fiberglass with resin. They lay 2 fiberglass layers in most parts of the mold, and a few extra layers in areas that need a bit more strength to support attached components. In the lower mold, they reinforce the floor with plywood, and in specific locations, bond in steel mounting plates for bolting components to the fiberglass later on. 24 hours later, once the resin has cured, they extract the upper and lower body halves from the respective molds, trim the rough edges, and join the halves on the inside with more fiberglass and resin. Then they place the now assembled body inside the perimeter chassis to check the alignment. But they don't connect the chassis just yet. First, to snazz up the body, they mount a nose badge made of stainless steel and anodized aluminum. Then they attach aluminum strips to the nose badge, affixing them to the fiberglass with rivets. They gently tap the strips with a mallet, shaping them to the contour of the body. Then they set a rubber insert into each strip. This adds a decorative touch while hiding the rivets. Next, the sidecar's windscreen. It's made of polycarbonate, an ultra-thin yet strong type of plastic, encased in a durable aluminum frame. They finish off the body by installing carpeting and an upholstered vinyl seat. Workers position the sidecar so that its wheel is turned slightly inward. This ensures the bike and sidecar handle correctly. Then they bolt the chassis to the bike frame with 4 steel arms, 2 at the front and 2 at the back. Next, they fit a steering damper. This prevents the sidecar from causing a wobble in the steering. The final step is to connect the electrical wiring to the lights in the mudguard. The perimeter chassis is now ready to receive the body. They thread bolts into the holes of those mounting plates that were bonded in with the fiberglass during the molding process. 2 bolts at the front and 2 at the back through the floor. With that, this motorcycle sidecar is ready to hit the road. Love French toast for breakfast, but don't have the time or patience to make it from scratch? That's why there's ready-made frozen French toast that you simply pop into the toaster. No cracking eggs, pouring milk, or dipping bread required. Just pour on the syrup and enjoy. A breakfast favorite for generations, it's easy to get sentimental about French toast. To get that traditional taste without the traditional mess, there's frozen French toast. They go from your freezer to your breakfast table in just minutes. French toast starts with freshly baked bread. A local bakery supplies this factory with custom-made 16-inch long loaves. When those fresh-baked loaves arrive, workers load them horizontally onto a conveyor belt. The belt winds its way to the first machine on the production line, the slicer. The slicer has several vertical blades, crossed in a figure 8, over 2 drums that drive them. Because each blade crisscrosses, it cuts 2 slices at once. For this production run, the slicer cuts each loaf into 28 slices, almost half an inch thick. At the output end of the slicer, workers discard the 2 end pieces. However, these heels, as they're called, aren't wasted. They're used for animal feed. Workers load the cut loaves into side-by-side vertical columns. The slices drop down onto a wire conveyor belt. The spacing between rows and slices is perfectly positioned to align with the upcoming stations, which will transform them from bread to frozen French toast. First, the slicer enters the batter station, which bathes their underside in a mixture of eggs, milk, water, and sugar. The slices then pass under a batter waterfall, which thoroughly coats their top surface. The slices exit the batter station onto a wire belt, which feeds them onto cast iron griddle plates. Gas flames underneath heat the plates to 275 degrees Fahrenheit. After several seconds, the underside is cooked, and a row of automated spatulas, appropriately called flippers, turns the slices over to cook the reverse side. Seconds later, the fully cooked French toast slices are removed from the griddle plates and deposited onto a conveyor belt. All the single-file conveyors now converge on a larger conveyor belt, which transports the slices into the freezer. The temperature inside? -4 degrees Fahrenheit. After a frosty 23-minute ride, the French toast is completely frozen. It exits the freezer, ready to be sorted into packaging portions. For this order, workers stack the slices in 4s. Each package will contain 2 stacks. The packaging machine inserts each portion into a continuous plastic film pouch. Then, at both ends of each portion, it simultaneously heat seals the film and cuts the pouch free. An automated arm picks up each pouch and inserts it either into small retail cartons destined for supermarkets or into large boxes for bulk orders to cafeterias, hospital kitchens, and restaurants. All packaging, warehousing, and shipping occurs in temperature-controlled facilities to keep the product frozen until it's time to toast this breakfast tradition. Behind every chilled beverage, there's a compressor, a crucial component in refrigeration systems. It pressurizes and pumps refrigerant to the condenser so the cooling process can begin. With a well-functioning compressor, a refrigerator is more likely to keep its cool. Behind the glossy exterior of a supermarket refrigerator, there's a substantial compressor doing its part to chill the merchandise. They often remanufacture old compressors to save resources and money. They immerse the cast iron body in a chemical bath to remove the grime and rinse off the residue with hot water. That old compressor already looks a lot less tired. A worker polishes the cylinder bore with an abrasive pad attached to an air drill. He sands the surfaces around the openings so that all the parts will fit without leaking. Smaller parts bounce around in a vibratory bowl with steel pellets and cleaning compound for a good scouring. Out of the bowl, a worker places a valve plate on a magnetized turntable to keep it in one place as a grinder smooths the surface. This makes it look new. He screws 2 new valves to the plate. These valves will open and close to move refrigerant in and out of the compressor. The next worker assembles the terminal plate for the compressor's electrical motor. Most of the components have been reconditioned, including the lugs for the wires. He slots the lugs in the terminal plate from the back and flips the plate around. He slides new rubber seals onto all the lugs and then installs rubber insulators and metal washers. He secures the lugs with screws using a precisely calibrated torque wrench. The compressor's original crankshaft has also been thoroughly cleaned. As it now spins in a chuck, a worker polishes it until it's completely smooth. This will allow bearings and connecting rods to operate efficiently. He measures the shaft to confirm that the circumference is right. With many parts now reconditioned and partially assembled, they're ready to reconstruct the compressor. The worker installs new bearings and the refurbished crankshaft into the compressor body. He inserts the connecting rod and piston assemblies. Moved by the crankshaft, these pistons will compress the refrigerant gas to pump it through the system. He slides the rotor part of the motor into the compressor, and it links up to the crankshaft. He aligns the rotor to the crankshaft with a long pin. He secures the rotor to the hub with a substantial bolt. The next part is the stator. It's the magnetized mechanism that drives the rotor and subsequently the crankshaft. He connects protruding wires to the lugs on the terminal board we saw reassembled earlier. He sets the terminal board flush to the compressor and bolts it to it. He fits the valve plate on the cylinders adjacent to the terminal plate. He places a cylinder head over the valve plate and bolts it to it. The remanufacture of this compressor is complete. To test the compressor, they pump dry nitrogen through it. A machine measures the suction and discharge pressure as well as the electrical draw. And still running dry nitrogen through it, they immerse the compressor in water and check for bubbles that would indicate leaks. They make repairs if needed, and then spray the compressor with enamel paint to protect it from rust. Remanufacturing this refrigeration compressor has taken 24 hours. It's given it a whole new lease on life. An engine naturally takes in air from the atmosphere to burn the fuel with oxygen. If you're looking to give your car a boost, a supercharger compresses air and force feeds it into the engine. The increased mass of oxygen burns more fuel, giving the engine more power. A supercharger is particularly popular in drag car racing. It attaches with a belt to the engine's crankshaft, and voila, the car's on steroids. They begin with a plate that forms the rear of the supercharger's aluminum housing. Using a press that applies several tons of pressure, they install 2 steel ball bearings. These will enable the supercharger's 2 rotors to spin, which is what compresses air and forces it into the engine. After bolting a steel cap over each bearing, workers insert steel dowels into holes along the perimeter of the plate. These dowels, which they now fully seat with a press, will align with receiving holes on the adjoining housings. They take the plate that forms the front end of the housing and press a steel ball bearing into it. This bearing will enable the supercharger's input shaft to rotate, and by doing so, spin the rotors. They press a rubber lip seal on top of the bearing to keep oil in and dirt out. Next, they apply a retaining clip to hold the seal in position. Using the press, they seat the clip in its groove. Next, they insert the input shaft. Its flanged end will protrude out of the supercharger, where a belt and pulley will rotate it so that it turns gears which spin the rotors. A computer-guided mill machines each rotor out of extruded aluminum. Once both rotors are ready, workers take the central section of the supercharger housing and apply sealant to one end of it. They affix the rear plate containing the 2 bearings for the rotors. They secure the plate to the main housing using socket-headed screws, which they tighten with an air driver. Flipping the housing to the other side now, they install the first of the 2 rotors, inserting its shaft into the first bearing in the just attached rear plate. Then they install the second rotor, inserting its shaft into the second bearing in the plate. The second rotor lies perpendicular to the first. This positioning allows the spinning rotors to capture air at the top of the housing, compress it, and force it downward to the bottom of the housing. They close up the housing with another plate, which also contains bearings for the rotor shafts. However, on this end, the shafts protrude beyond the bearings in order to receive gears. Then to this, they'll attach the housing containing the input shaft, which, driven by the belt and pulley, rotates these gears to spin the rotors. Before continuing further, the team puts the supercharger through a performance test. The machine, called a dynamometer, assesses the ratio of speed to airflow to ensure the rotors are compressing air the way they should be, and therefore outputting the required boost. If the rotors pass the test with flying colors, Workers then hand polish the aluminum housing to a shiny finish. A key component in the supercharger is a feeler gauge, that fan-shaped part shown on the lower left. It ensures that the distance between the rotors is correct, which is critical, because if the rotors are too far apart, they don't compress air adequately, and if they're too close together, they jam. It's the customer who, when installing the supercharger, attaches a pulley to the end of the input shaft, then a belt onto the pulley. The other end of the belt loops around the car engine's crankshaft pulley, connecting the supercharger to the engine for a mega boost of power. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/how it's made.